Hello guys, welcome to the chemical engineering example number 2. Today I'm going to cover 4 equations for catalyst calculation. It will cover how to calculate the catalyst pore radius, what is the external surface area of a catalyst, the catalyst density, as well as the porosity. So let's jump to the first example, average pore radius of catalyst particle. The two things you need to know for this calculation is you need to know what is your catalyst surface area and what is your catalyst pore volume. For this calculation, I'm starting with a catalyst surface area of 100 square meter per gram, and my catalyst micropore volume is around 0.3 cubic centimeter per gram. So the equation to calculate the average pore radius is to multiply the catalyst pore volume divided by the catalyst surface area. Here is the outcome. As I mentioned, the average pore radius of catalyst particle is to multiply the catalyst pore volume divided by the catalyst surface area. And starting with 100 square meter per gram as the surface area, 0.3 cubic centimeter gram as the pore volume, the calculated average pore radius for this catalyst is 6 nanometer. Next, I'm going to jump to the second equation, the external surface area of a catalyst particle. To calculate the external surface area of a particle, you need to know what is the particle diameter and what is the particle density. The equation to calculate the external surface area is 6 divided by the catalyst particle diameter times catalyst particle density. The catalyst particle density is 1.43 gram per cubic centimeter, and the particle diameter is 1 micron. Again, the result is shown here at the bottom. The external surface area equals to 6 divided by catalyst particle diameter multiply catalyst particle density. So in this case, the diameter is 1 micron and the catalyst density is 1.43 cubic meter per gram. So using these two parameters, the calculated external surface area is around 4.2 square meter per gram. Now, as you can see here, if we go back to this example 1, the catalyst surface area is 100. So that's the total surface area. And the calculated external surface area is around 4. So you can see the majority of the catalyst surface actually comes from the internal pores. Now let's jump to the third equation, catalyst density calculation. Basically, the catalyst density can be calculated using the catalyst mass divided by the catalyst volume, but depend on how we define the volume of the catalyst. The catalyst density can be calculated in different ways. For today, I'm going to use a catalyst pellet as my starting example because for most of the application, in order to reduce the pressure drop in the pipette reactor, a catalyst pellet is used instead of catalyst powder. So for this catalyst pellet, we know the weight is 2.0 gram, the pellet volume is 2.2 cubic centimeter. The micropore volume of this catalyst pellet is 0.3 cubic centimeter per gram, and the macropore of this catalyst pellet is 0.4 cubic centimeter per gram. So the micropore I mentioned in this case is actually the pore within the catalyst particle, and the macropore is the void space between the catalyst particle. So these two are quite different. One technique we can get this information is using mercury penetration method. Now let's go to the example. First, we can calculate the catalyst pellet density. So we know the weight of the pellet, we know the volume. So the result is shown here at the bottom. The density of the catalyst pellet is 0.91 gram per cubic centimeter. Now we know what is the density of the pellet. The next question is how to calculate the density of the particle. So to calculate the catalyst particle density, what we need to know is we need to exclude the micropore volume within this palette. As I mentioned earlier, that can be characterized by using the mercury intrusion method. So if we exclude the micropore volume in this palette, we can calculate the catalyst particle density, and in this case, it is calculated as 1.43 gram per cubic centimeter. And as we know that most of the catalysts are porous, if you want to calculate what is the catalyst particle true density, what you need to do is, besides excluding the micropore volume within this palette, you also need to exclude the micropore volume. And again, this information can be obtained by using the mercury porosimetry method. So the calculation is basically using the weight of the catalyst particle and the total volume minus the micropore volume plus the micropore volume of the catalyst. And from the calculation, you can see here, the catalyst particle true density is around 2.5 gram per cubic centimeter. So what you can see here is the catalyst pellet density is less than the catalyst particle density, and that is also less than the catalyst particle true density. Now let's go to the fourth equation, which is the catalyst porosity. So the catalyst porosity is the volume of catalyst divided by the total volume of the catalyst. Or in other words, you can use the volume of the catalyst per gram multiply the catalyst density. So let's go to the example. As we shown earlier, the catalyst pellet weight is 2.0 gram, the catalyst pellet volume is 2.2, the micropore volume of this catalyst pellet is 0.3, and the micropore volume of this catalyst pellet is 0.4 cubic centimeter per gram. First, let's calculate the total pore volume, basically by adding the 0.3, 0.4 together. Then let's calculate the density of this catalyst pellet. Basically, it's the catalyst pellet weight divided by the catalyst pellet volume. Now, the catalyst pellet porosity can be calculated using this total pore volume per gram multiply the catalyst pellet density. And the result is shown here. For these pellets, in this example, the porosity is around 0.64. Besides the porosity, I also want to show you how to calculate the micropore word fraction. Basically, the calculation is you need to know what is the micropore volume of the catalyst pellet per gram, and then you divide the volume of 1 gram catalyst pellet using this 1 divided by the catalyst pellet density. And the same calculation can be applied to this micropore word fraction. Again, you need to know what is your micropore volume of the pellet per gram. Then you divide it by the volume of 1 gram catalyst. Next, if you know your micropore word fraction, your catalyst fraction in this example can be calculated using 1 minus the micropore word fraction minus the micropore word fraction. So for the pellet I showed in this example, the micropore word fraction is 0.27, the micropore word fraction is 0.36, and the catalyst fraction is around 0.36. So now to visualize today's calculation, as shown in figure 1, the pellet density is less than the catalyst particle density, and that is also less than the catalyst true density. And on figure 2, what I showed you is the volume fraction of different components in this catalyst pellet. As you can see, the micropore is less than 30%, and the micropore and the catalyst is around 36% of the total volume. So to summarize, today we showed 4 equations for catalyst calculation. The first one is the average pore volume of the catalyst particle. The second one is how to calculate the external surface area of a catalyst particle. The third one is how to calculate the catalyst density. And the last one is how to calculate the catalyst porosity. I hope you feel this video is helpful. Thank you for watching.